In this video, we will be discussing about count servers that communicate. You are given a map of a server center represented as a m cross n integer matrix grid, where 1 means that on that cell there is a server and 0 means that it is no server. Two servers are said to communicate if they are on the same row or on the same column. Return the number of servers that communicate with any other server. So what they are saying is that in the input, we are given an integer matrix of m cross n grid, right? Here, we are having only two values, 1 and 0. 1 denotes that we have a server and 0 denotes that no server or basically empty, right? So now one server can communicate with any other server which is present on the same row or on the same column, right? So for example, if we see here, this is a server, on its same column we have another server, right? So these two can communicate with each other, right? Now our goal is to identify that how many servers in our grid are communicable. Basically, how many of the servers can communicate with any other server, right? So that count we need to return. So if we see in this particular case, for this server, there is no other server on the same row or on the same column, so this won't be counted. Then for this server, again, there is no server on the same column, no server on the same row, so this will also not be able to communicate. So here the answer will be 0. Then if we check here, for this server, we have one other server on the same column. So this is communicable. And for this also, we have on the same column. So both of these can communicate. Then for this server, we have another server on the same row. So this is also communicable. So here our answer is going to be 3. Then if we check for this particular grid, so here for this server, we have another server on the same row, right? So these two can communicate with one another. Then for this one, we have one other server on the same column. So these two can also communicate. But for this one, there is no other server on the same column, no other server on the same row, right? So here our answer is going to be 4, right? So now how are we going to solve this? So see, in the brute force approach, what we can do is that we can start iterating or we can start checking each of the cells in our grid, right? Wherever a grid is 1, meaning we have a server, what we need to do is we need to iterate once for its row and once for its column, right? And if there is any other cell other than this, which is also having a 1, meaning it is also having a server, so we will count this in our answer, right? So basically, if this is the cell, first we will check its row. If there is any other cell containing a 1, we will count it. If not, then we will check its column. If there is any other cell with a 1, then we will count it. And if not, then we will just move to the next cell because this is not communicable. So this is the brute force. So basically, first you would be running a for loop m cross n times, and then inside of that you will be iterating for the column and the row. So basically it will be into m plus n. Somewhere around this will be your time complexity. And the constraints that are given to us for m and n is maximum 250 cross 250. So I think it will work, but let's try to optimize it and think of a better solution. So see, a particular server will be communicable only when we have another server in the same row or in the same column, right? So does it give you a hint of knowing how many servers are present in a particular row or in a particular column? So if let us suppose somewhere I have this information that in a particular row, these are the number of servers, and in a particular column, these are the number of servers. Then what I can simply do is that if this is a server, if in this column I am having other servers also, basically the count is greater than 1 for either the row or the column. So I can say that this server is communicable because this server just need one other server anywhere in the same row, anywhere in the same column, right? So what we can do is that we can maintain two arrays over here. One will be the row count and other one will be the column count, right? So these are the two arrays. 0, 1, 2, 3, 0, 1, 2, 3. So basically this array will store that, okay, in row 0, how many servers are there? In row 1, how many servers are there? And this will store in column 0, how many servers are there, and so on, right? So to update this, what you can do is that you can start iterating for each of the cells in the matrix. So this is a server. This is present at 0, 0. So what we will do is that in the row counts array at the index 0, we will increment by 1, and in the column counts array at the index 0, we will increment by 1. So this will become 1 and this will become 1. Then we will come at this cell. So this is at 0, 1. So here we will update by 1 and here we will update by 1, right? So this will become 2, this will become 1. Then this is no server. Here we have a server. So for this, here we will update and here we will update. This will become 1, this will become 1. Next we have this server. So this will become 1 and this will become 2, right? So this will be here 1 and here 2. And then for this server, here we will update by 1, here we will update by 1. So now we know that in each row and in each column how many servers are there. Now what we can simply do is we can start checking this matrix again. So we see here we have a server, right? So we will check that in its row or in its column, if any of them is having the count greater than 1, then that means there is some other server in the same row or the same column with which this server can communicate. So we will count it, right? So here for this one, here we are having count greater than 1. So we will count it. Then for this one, again we are having count 2 over here. So we will count this. Then for this server, here we are having count greater than 1. So we will count it. Then here also we are having count greater than 1. So we will count this as well. But for this one, here also the count is not greater than 1 and here also the count is not greater than 1. So this won't be counted. Only these four will be counted and that is our answer, right? So this is how we can solve this problem. Now let's quickly look at the code. So first of all, let's take the size of the grid. So int m will be equals to grid dot size and n will be equals to grid of 0 dot size, right? Now we need two vectors. One will be for the row count and one will be for the column count. So vector int row counts, its size will be equals to m, and initially we can keep all the values as 0, and the other one will be the column counts. Here the size will be n and all the values will be 0 initially, right? Then we will run a for loop of I starting from 0 going till m and then I plus plus. Inside this we will run another for loop of j starting from 0 going till n and then we'll do j plus plus. Now inside this we need to check that if grid of I of j is equals to 1. So if you will write like this, then only whenever it is 1, it will be true. If it is 0, it will be false, right? So if it is 1, then in that case, in the row counts vector, at the index I, we will increment it by 1. And in the column counts vector, at the index j, we will increment by 1, right? Now that we have updated our row counts and column counts vector, we will find our answer. So for that, let's create an answer variable and initialize it to 0. Then we will run a for loop of I starting from 0, going till m, I plus plus, and then inside that another for loop of j starting from 0, going till n, and then j plus plus, right? Now inside this again, we need to check that if grid of I comma j is equals to 1, that is it is a server, we need to check that in its corresponding row or in its corresponding column, do we have a count greater than 2 or not, right? So if it is, then we need to add a plus, otherwise a 0. So what we will do is that in the answer, we will add row counts of I greater than 1 or column counts of j greater than 1. So if any of the condition is true, then it will add 1 to the answer. And if both are false, then it will add 0 to the answer, right? And then at the end here, we can just return this answer. So let's run this now. So as you can see over here, here we are running a for loop m cross n times, and then here we are running another for loop m cross n times, right? So the time complexity over here will be m cross n. And coming towards the space complexity, so here we have taken an extra space, right, for storing our row counts and column counts. Row counts is equals to m and column counts is equals to n. So we can say that the space complexity is m plus n, right? So now let's try to submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.